Imagine you are a scientist, a materials engineer. You have a PhD from MIT. You have 30 years of experience. You have access to electron microscopes, X-ray diffraction technology, and the most advanced laboratory equipment on the planet. And your job today is to figure out how to build a wall that gets stronger over time. Not weaker, not the same. Stronger. Every year that passes, stronger. You work on it for decades. And then one day a colleague walks into your lab and quietly says, "The Romans already solved this 2,000 years ago with volcanic ash and seawater. And we still cannot fully replicate what they built." That is not a story about how smart the Romans were. That is a story about how completely we have underestimated what the ancient world was capable of. And it is just one story of many. Because there is a pattern in human history that nobody talks about. A pattern where ancient people solved problems so far ahead of their time that we spent centuries being confused by the answers they left behind. Today, we are going to talk about 5 of those answers. And I promise you, by the time we are done, you will never look at the word primitive the same way again. This is Ancoria, and this is where we begin. Let's start with the wall. In 79 AD, the same year Mount Vesuvius buried Pompeii, a Roman historian named Pliny the Elder wrote something peculiar in his Encyclopedia of Natural History. He wrote about Roman harbor concrete, and he said it becomes, as soon as it comes into contact with the waves of the sea, a single stone mass, impregnable to the waves and every day stronger. Every day stronger. For almost 2,000 years, historians assumed he was exaggerating, because that is not how concrete works. Concrete weakens over time. Every engineer on Earth knows this. Modern concrete bridges, built with the best technology we have, are designed with a lifespan of 50 to 100 years. After that, they start to fail. So how are Roman harbor walls, built in 20 BC, still standing in the Mediterranean, not just intact, but actively getting stronger with every passing decade? The answer came in 2017, when researchers from the University of California, Berkeley, drilled cores from ancient Roman harbor structures and analyzed them with X-ray technology. What they found stopped them completely. The Romans had mixed their concrete with volcanic ash, lime, and seawater. And as the seawater slowly percolated through the volcanic ash over centuries, it was growing a mineral called aluminum tobermorite, a rare crystal that forms inside the concrete matrix and reinforces it from the inside out. The concrete was not just surviving, it was healing itself, growing stronger, becoming more like rock with every passing year. A 2023 study from MIT and Harvard finally confirmed the self-healing mechanism, and modern engineers are only now learning how to replicate it. Only now, 2,000 years later. And here is the part that makes you sit back in your chair. The Romans did not stumble onto this. Pliny the Elder described the recipe in 79 AD as if it was standard knowledge. As if every builder knew it. They knew exactly what they were doing. They understood that seawater was not the enemy of their concrete. It was the ingredient. We built an entire civilization using Portland cement that crumbles in seawater. Because we forgot what the Romans already knew. Now I want to ask you something personal. Have you ever held a knife so sharp it frightened you a little? The kind of sharp where you knew, if you were not careful, something bad was going to happen. In the medieval Middle East, there was a steel so far beyond that it has become legend. It was called Damascus steel. And the stories that surrounded it were almost impossible to believe. Swords made of Damascus steel could allegedly slice through a falling strand of silk before it hit the ground. They could cut through other swords without losing their edge. They were so hard they could shatter inferior blades and so flexible they could bend almost in half without breaking. These are not myths. Modern metallurgists have examined surviving Damascus blades and confirmed that the steel contained carbon nanotubes, microscopic cylindrical structures at the atomic level that give the blade extraordinary strength and flexibility. Carbon nanotubes were considered a breakthrough of modern materials science. A 21st century discovery. Medieval swordsmiths in Damascus were making them without a laboratory, without a microscope, without even knowing what an atom was. The exact method of producing Damascus steel was a trade secret among Middle Eastern swordsmiths that dated back 20 centuries before the deposits of ore they relied on simply ran out in the early 1700s. bringing an unceremonious end to a metalworking tradition we have never fully recovered. Modern metallurgists have spent decades trying to replicate the exact properties of Damascus steel. They have come close, but not all the way. The full secret died with the last swordsmith who knew it. Think about that for a moment. Somewhere around 1700, the last person on Earth who knew how to make the strongest blade in human history died, and took the knowledge with them. We have been searching for it ever since. But there is a discovery that makes Damascus steel and Roman concrete look almost ordinary by comparison. Because at least with those we understand what we are looking at. In the year 1900, a group of Greek sponge divers were sheltering from a storm near a small island called Antikythera. One diver went below and surfaced in shock. He told his companions the ocean floor was littered with statues. They thought he had nitrogen narcosis, a condition that causes hallucinations in deep water. But when others descended, they saw it too. The remains of an ancient Roman ship, filled with bronze statues, marble sculptures, gold jewelry, and glass, and one corroded green lump of bronze. Nobody paid much attention to it. It was cataloged as debris. Then, in 1902, a museum worker cleaning the artifacts noticed something inside the lump. Gears. Tiny, precisely cut bronze gears. Inside a 2,000-year-old piece of wreckage. As cleaning continued, the results were astonishing. The device contained a sophisticated arrangement of interlocking gears designed to reproduce astronomical cycles. Some gears had very specific numbers of teeth, carefully chosen to match known celestial periods. It was a machine, a computing machine, built in ancient Greece around 100 BC. It could calculate the positions of the sun and moon. It could predict solar and lunar eclipses. It could track the 4-year cycle of the Olympic Games. It modeled the movements of all 5 planets visible to the naked eye, with 30 interlocking bronze gears. Crafted by hand, 2,000 years ago. The device is now called the Antikythera Mechanism, and here is what historians say about it. It is the most sophisticated mechanism that survives from antiquity. For 1,000 years after the fall of the Roman Empire, no workshop or lone genius produced anything as complex. 1,000 years. After Rome fell, it took humanity 1,000 years to build something as mechanically sophisticated as a device that a Greek craftsman built by hand 2,000 years ago. And more than half of it is still missing. Still sitting on the ocean floor, near Antikythera, waiting. Imagine what the complete version could do. Now there's one more story I need to tell you. And this one is different, because this is not about something we lost the ability to replicate. This is about something we lost completely. The formula, the recipe, the knowledge itself. Gone. In the 7th century AD, the Byzantine Empire developed a weapon that changed the nature of naval warfare forever. It was called Greek fire, and it did something that should have been impossible. It burned on water. Not beside water, not near water, on water. You could pour it on the sea and it would ignite and burn. You could try to douse it and it would burn brighter. Enemy ships caught fire and there was nothing their crews could do. The Byzantine navy used Greek fire to defend Constantinople against Arab fleets not once, not twice, but multiple times, destroying armadas of hundreds of ships with this single weapon. The formula was so valuable, so strategically critical, that the Byzantine Empire treated it as the highest state secret in their possession. Only a handful of people in the entire empire knew the recipe at any one time. It was never written down, passed from person to person, in whispers. And when Constantinople fell to the Ottoman Empire in 1453, the last person who knew the formula apparently died in the siege. And the secret died with them. We have a rough idea of what it was probably made out of. Crude oil, pine resin, sulfur, quicklime, or saltpeter. But despite numerous attempts, modern researchers have never been able to recreate Greek fire. Never. Not even close. We have launched satellites. We have split the atom. We have mapped the human genome. And we cannot recreate a weapon that Byzantine sailors used 1,200 years ago. So what does all of this mean? It means something I think we need to sit with for a moment. We tell a very comfortable story about human progress. The story goes, things keep getting better. We keep getting smarter. Each generation builds on what came before. And mostly, that story is true. But hidden inside that story is another truth. The truth is that knowledge is fragile. More fragile than stone, more fragile than steel, more fragile than concrete. The Antikythera Mechanism was not ahead of its time because ancient Greeks were geniuses who nobody understood. It was ahead of its time because the civilization that could produce it collapsed and took the knowledge with it. Damascus steel did not vanish because the swordsmiths lost interest. It vanished because a specific ore from a specific region ran out, and the knowledge built around that ore had nowhere left to go. Greek fire did not disappear because it stopped working. It disappeared because the last person who knew it died in a battle. On a Tuesday, like any other day. And nobody thought to ask them first. That is the part that stays with me. Not the genius, not the achievement, the fragility. The way 1,000 years of knowledge can end, not with a grand collapse, but with a single person drawing their last breath without passing something on. These were not primitive people. They were people exactly like us, curious, inventive, brilliant, solving problems with everything they had. And some of what they solved we are still reaching for. So the next time you see the word ancient and feel the word primitive rising in your mind, remember the Roman wall still getting stronger in the sea. Remember the Damascus blade that cut through silk and still has no equal. Remember the gears on the ocean floor waiting to tell us something we forgot. And remember the fire that burned on water and took its secret quietly to the grave. The ancient world was not less than us. In some ways, it knew things we are still trying to learn. And that is why these stories matter. That is why we tell them. This is Ancoria. We will see you in the next one.